You are welcome to today's meeting. Today we are going to look at the topic called indices. Indices. So by the time we finish this meeting, we should be able to achieve these objectives. One, we should be able to state the basic laws of indices. Two, we should do some simplification of expression involving indices. Then you should be able also to solve some problems involving indices. So let's look at indices. Indices are the mathematical expressions that involve powers or exponents or index. Powers, exponents, or index are the same. So imagine we have an expression a power m or a exponent m or a index m. A is the base and m is the power or exponent or the index. So we are having an expression like this. The down here becomes the base, and then the power top here becomes the power or the index or the exponent. So a power m means we are going to multiply a by itself m times. So a power m means we are going to multiply a by itself m times. So for instance, if we have 4 power 3, it means we are multiplying 4 by itself 3 times. So we have 4 times 4 times 4. So we have 4 power 3. Now if we have into bracket -5 all power 6. Now it means that we are going to multiply -5 by itself 6 times. So -5 times, -5 times, -5 times, -5 times, -5 times, -5. Good. Here the exponent affects the negative. That's why we have a negative inside the bracket. But let's know this. -5 power 6 is not the same as -5 all power 6. Now with this part, the power does not affect the negative, but it only affects the number 5. But for this one, the power affects both the negative and 5. So example, if you have -3 power 5, it means we can express this one as -1 times now 3 times 3 times 3 times 3 times 3, 5 times. But negative only affects the 1. It means the power has no effect on the negative. That's why I said -5 power 6 is not the same as -5 all power 6. Good. So let's move on. Let's go straight to the basic laws of indices. The laws of indices. The laws of indices. So let's go to law 1, or rule 1. And we have the multiplication laws of indices. The multiplication law of indices. Now if I have a power m times a power n. Now here the base is a, the base also, so the base are the same. There's a matter of taking one of the bases and just add the exponents. So it becomes a power m plus n. A power m plus n. So it means if you have a power m plus n, we can also express this as a power m times a power n, vice versa. So if you're having a power m times a power n times a power p, now all the three numbers here are having this. So we can just take only one of the bases, and add the exponents. So we have a power m plus n plus p. Multiplication normally goes with addition. So when the numbers are multiplied with the same basis, we just take one of the bases and just add the powers. Example: 3 power 6 times 3 power 2. So here we can see that the power here, the base is a now is 3, and the power here m is 6. Now the base here a is 3, the power n is 2. So to me, you are multiplying 3 by itself 6 times here. I multiply 3 by itself 2 times, as you see here. So you have 1, 2, 3, 4, 5, 6. That is 3 power 6. Here we have 1, 2. Here should be 2. This one should be cancelled. So this one is not part. So we have 3 times 3. Therefore, by counting all of them, you have 1, 2, 3, 4, 5, 6. That one would be 3 power 6. And we have 1, 2, 3 power 2. Hence, we have 3 power 8. Now, if you are going by the law here, or the rule here, we have 3 power 6 times 3 power 2. It's the same as 3 power. Now, let's add the powers. So, 6 plus 2. That's what you see here. So, by adding 6 to 2, we have 3 power 8, which is the same as going by the normal way. Good. Now, if you have 4 power 3 times 2 power 4 times 8 power 2, at this point, the bases are not the same. So we cannot go straight to apply the law here. But we have to check if we can express 4 and 8 as base 2 power something, so that all of them have the same base 2, 2, 2. I know we can express 4 as 2 power 2. We can express 8 as 2 power 3. So now we are not going to have 2 power 6 times 2 power 4 times 2 power 6. Now, by applying the basic law of multiplication, since the bases are the same, take one of the bases and just add the exponents. So it will be 2 power 6 plus 4 plus 6, which is called 2 power 16. Let's see another example. 0.1 times 0.01 times 0.001 times 10 power 7. Yet with the bases are not the same, but we can equally do so by just writing this one in the standard form. So 0.1 becomes 1 times 10 raised to the power negative 1, as you see here. 0.01 becomes 1 times 10 raised to the power negative 2. By just removing the point here, 1, 2. So if we are moving 2 times, they become 10 power 2. But if we are moving from right or the left to right, the power becomes negative. When we move from the right to left, it becomes positive. So when we can be the same way, we have 1, 2, 3. Therefore, it becomes 10, 1 times 10 power negative 3. Now multiply by 10 power 7. So we could see that we now have all of them being 10 power negative 1 times 10 power negative 2 times 10 power negative 3 times 10 power 7. So all of them now have the same base, which is 10. Hence, we can take one of the bases, making 10, and then add the powers. Don't forget 1 times 10 power negative 1 is the same as 10 power negative 1. Good. So let's go to the root number 2, or the law 2. That was also called the division law of indices. The division law of indices. So if you have a power m divided by the same a power n, yet to the base are the same, a. Then since multiplication goes with addition, then division also goes with subtraction. So here we are going to take one of the bases and then we subtract the numbers. So a power m divided by a power n can also be expressed as a power m over a power n. Now this is equal to, now you have a power m minus n. We take one of the bases and just subtract the second power from the first power. We can equally apply the multiplication law here by pushing this a power n to the top here and to come and multiply a power m to give you as times a power negative n. We shall look at this law or the rule later. So example, 5 power 6 divided by 5 power 3. If you are going by normal way of solving this, it's the same as you multiply 5 by itself 6 times over you multiply 5 by itself 3 times. So we have 5 times 5 times 5 times 5 up to 1. Over 5 times 3 times 5 times 5 times 5 3 times. Therefore, this will cancel one of this, and this will also cancel one of this. This will also cancel this. Good. Now, so looking at the number of 5 that you have 1, 2, 3. Therefore, the answer becomes 5 power 3. Now, we can also apply the law. So 5 power 6 divided by 5 power 3. Take one of the bases, 5 here, then subtract 3 from 6. So you have 5 raised to the power 6 minus 3, which will give us 5 power 3. Another example, 3 power 5 divided by 9 power 3 divided by 27 power 2. At this point too, the bases are not the same, and for that matter, we have to check if we can express this basis in terms of this small base here, 3, to see if you can get all of them being the same. But 9 can be expressed as 3 power 2. So multiply that 2 by this, we get 3 power 6. 27 can be expressed as 3 power 3. Multiply that 3 by this 2 also give you 3 power 6. So therefore, we can express this as 3 power 5 divided by 3 power 6 divided by 3 power 6. So now the bases are the same, so we cannot take one of the bases, the 3 here. Then we subtract the powers. So it becomes 5 minus 6 minus 6. And the answer becomes 3 power negative 7. The third law. if there is a negative indices on a number, then a power negative m can also be expressed as a 1 over a power m. So if you want to move the negative power from there, the negative sign from there, then the thing becomes 1 over that number. In the same way, we have 1 over a power m. I can push a power m also up to multiply by this 1, and that will give me a power negative m. Good. Or if I have a power m, I can also bring it down. And when it comes down, it also becomes 1 over a power negative m. 1 over a power negative m. So for example, 1 over 4, by pushing this 4 up here, we are going to get it as 4 power negative 1. 4 over 2 power 3. By pushing this 2 to multiply by the numerator number here, 4 here, becomes 4 times 2 power negative 3. In the same way, we can also put this one down to become 4 over 2 power 3. So you can go top, can come down. So with this, we are now having 4 here, you're having 2 here. So you can express 4 as 2 power 2 times 2 power negative 3. So this time around, we can apply the multiplication law instead of a division law. Or we can separate division law. And we get the same thing. So taking one of the bases, we have 2. Now the powers are 3 plus negative 3, which is the same as 3 minus 3. And the answer will be 1 over 2. Don't forget, this is the same as 4 over 8, and 4 over 8 is the same as 1 over 2. That's the answer here. Let's move on to the next law. Now here, if there are indices on indices, then indices are multiplied as if you are having a power m or power n. So we have 2 indices, m and n. So what will happen that way, we can just multiply the powers, m by n. So we have a power m times n. An example is 4 power 3 or power 2. So it becomes 4 power 3 times 6. 2 times 3 is 6. A power m or power 1 over n. So by multiplying m by 1 over n, it becomes a power m over n. So if you have, let's say, 5 power 2 or power 1 over 3, so the powers will multiply by themselves. And that will give you 2 over 3. Hence, it becomes 5 raised to the power 2 over 3. If you're having a power m or power n or power p, the same way, we are going to multiply all the powers here to get a power m times n times p. An example of this: 2 power 3 or power 2 or power 4. That will be 2 power 3 times 2 times 4, the same as 2 power 24. So let's look again into the indices or flashline indices. Flashline indices. But before then, let's look at this. A over b all power m Now the same as this A is power 1, B is also power 1. So the same as multiply the powers. So it becomes A power M all over B power N. So the power here will affect both A and B. For example, if you have 2 over 3 all power 3, it becomes 2 power 3 over 3 power 3. So this power will be affecting here and here. And the answer will be 8 over 27. Now, if you have A over B all power M, A over B all power M. Now, as we look at it before, if you want to get away with this M, then we have to push this one down. It becomes 1 over A over B. And that one will finally give us B over A power M. It means if you are having A over B power negative M, it's a matter of reciprocate the fraction, sending the numerator up here and bring send the numerator down and the denominator up. So we are interchanging A and B. The sign will go away. So we have A over B all power negative M becomes B over A power M. And that will further give us B power M over A power M. Example. 3 over 4 all power negative 3. So this one becomes, now bring 4 up, 3 down. So it becomes 4 over 3 all power 3. And hence it will be 4 power 3. Now we have also 3 power 3, which will be 64 over 27. Then in similar manner, we have 8 over 125 all power negative 4 over 3. So we are going to change 8 and 125. We are going to reciprocate them. So it becomes 125 over 8. Now the sign negative sign will go away. All power 4 over 3. And we can further express this one as 5 power 3. We can also express this one as 2 power 3. So you get something like this. All multiplied by 1 over 4 over 3 is also multiplied by 4 over 3. And the answer now becomes 5 power 4 over 2 power 4, which will give us 625 over 16. Now, again, for any real number A greater or equal to 0, that's a positive, and any integer M and N with N greater than 1. We have N here. So N should be greater than 1. And should be an integer. M must also be integer. So A power N 1 over N. A power 1 over N can also be expressed as the nth root, the denominator here of the power, denominator here. The nth root of A. So any number of roots of power, a fraction, becomes, let's say, A power 1 over 3, here, A power 1 over 3 here. If N is still here, then you have the third root of A. Again, A raised to the power 1 over N. This 1 over N is the same as the nth root of A. The denominator here is the N. So the nth root. That's what you see here. So you have the nth root of A. Again, if you have A power N over N, we can express this as A power M all power 1 over N. So this will become the nth root. So therefore, we are not going to have the nth root of A power M, as you see here. Again, a power m over n can be expressed as a power m multiplied by power 1 over n, or a power m all power 1 over n. And this power 1 over n is the same as the nth root of a power m, as you see here. Note, any real number a power 0 is 1, except when a equal to 0. Thus, a power 0 equal to 1, but a should not be equal to 0. Example, evaluate the following. 16 raised to the power 1 over 4. 7 raised to the power 1 over 2 times 14 raised to the power 1 over 2. 8 raised to the power 2 over 3, and 81 raised to the power 3 over 4. So we have 16 power 1 over 4 becomes the fourth root of 16. And the fourth root of 16 is 2. You can check it from your calculator. Fourth root of 16 is 2. If you are going by the other way, we cannot express 16 as 2 power 4. So we get 2 raised to the power 4, all raised to the power 1 over 4. So we can multiply the powers, and that will give us 2 raised to the power 1. And 2 power 1 is the same as 2. 2 power 1 is the same as 2. Good. Let's go to II. 7 power half times 14 power half. Now, if you want to apply the law of indices, the multiplication law here, we can't do so because here is 14 and here is 7. But we know 7 power half is the same as the second root, and second root is the same as the square root. Because the denominator is 2, so the second root. And second root is the same as the square root. So 7 raised to the power half is the same as root 7, as you see here. So times 14 can also be written as square root of 14. Square root of 14, or the second root of 14. Now root 14 can be written as root 2 times root 7, which is the same as square root of 14. Therefore, I can express this as root 7 times root 2 times root 7. So this one becomes the root 14. The root 14. And the answer will be that we multiply root 7 by root 7, it will give us 7 multiplied by root 2. Or we can apply the multiplication law here. Get 7 power half times 7 power half. And it will be the same as 7 power half plus half, which is the same as 7. Now multiply by root 2. So the answer will be 7 root 2. The third one, this can be expressed as 8 power 2 all power 1/3, as I told you so. So we have 8 power 2 all power 1 over 3. Therefore, we have the third root of 8 power 2, as you see here. The third root of 8 power 2. And the third root of 8 is 2. Now raised to the power 2, it becomes 2 power 2 equal to 4. Now if you are going by the other way, we can express this 8 as 2 raised to the power 3. Therefore, it becomes 2 raised to the power 3 all power 2 over 3. So by multiplying the powers, but multiply the powers. So this 3 will cancel here. This also will cancel here. So we have 2 raised to the power 2, which is the same as 4. Which is the same as 4. So let's go to the last one. 81 raised to the power 3 over 4. In the same manner, we can express this one as 81 power 3 or power 1 over 4. Therefore, we are not going to get the 4th root. We are going to get the 4th root. So it's the 4th root of 81 power 3. That's what you see here. The 4th root of 81 is 3, all power 3. So we are having 3 power 3, which is called 27. We can also express this one as 3 power 4. And that will multiply by, the power will be multiplied to get 3 power 3, which is also 27. I hope you are following. Now let's see how to simplify the following. Now we have already learned that the 4th root is the same as raised to the power 1 over 4. It's the square root. So this is all power 1 over 2. And this one will also all power 1 over 5. So solution, we have the 4th root of x power 16, y power 8 will be equal to, now into bracket, x power 16, y power 6, all power 1 over 4. That's the 4th root. So now you can multiply the powers through. So to give us x power 16 times 1 over 4, y power 8 times also 1 over 4. So by simplifying, this one will give us x power 4, y power 2. X power 4, y power 2. 4 goes here, 2. 4 also goes here, 4. So that's why you got x power 4. Now, y also power 2. Good. So let's do the I. We're having square root of 25a power 4 times b power 10. And the second root, that's what we don't see any number here. So for that matter, we are now going to raise all this, all power half. So it means I'll raise the power 25 power half times a power 4 power half times b power 10 power half. By root of 25 is 5, or the same as 5 power 2, or multiplied by power half. So we have this 2, we'll cancel this 2 here. Now when we go to a power 4 or power half, this will also cancel this one, leaving 2. Now when you come here, 2 will also cancel 10 here, leaving 5. Therefore, we now have 5a squared b power 5 as your final answer. I hope you are following. Good. So we can do the same thing to the third one. That is 5th root of 15x cubed y power 15. 5th root of 15x power 3 y power 15. Okay. So in the similar manner, we can just express it as into bracket 15 x cubed y power 3 all power 1 over 5. So that we multiply the powers, 1 over 5 through by the powers. So we have 15 power 1 over 5 x power 3 times power 1 over 5 y times 15 y power 15 times 1 over 5. And by cancellation or by simplifying, we are now going to get 15 power 1 over 5 x power 3 over 5 then y power 3. Good. Now we can try the following. Simplify this expression. Try it on your own. Now let's move on to exponential equations. Exponential equations. And we are going to apply this property. If a power m equal to a power n, here too we have the base being the same, but one term at the left side and the other term at the right side. So we have a power m equal to a power n. Now, for this equation to become, or for this equation holds, then if the bases are the same, the powers must also be the same. So if you have a power m equal to a power n, then m must be equal to n. So whenever you're having an equation with the two terms with the bracket or the equals are separating them, and where the base be the same, it's a matter of just equating the top. In the same manner, if the powers two are the same, then we can also equate the base. So we have the two ways. When the bases are the same, then the powers must be the same. When the powers are the same, the base must also be the same. Example 1. Find the values of the variables in the following equations. Find the values of the variables in the following equations. I, 2 raised to the power x equal to 64. I, 3 raised to the power 2x equal to 1 over 81. Third one, 2 raised to the power x equal to 1 over 128. You have 4 raised to the power 3x equal to 4 raised to the power 2x minus 6. You have 8 into bracket, 2 raised to the power 4x plus 3 equal to 4 raised to the power negative x plus 6. Next one, you have x cubed times x raised to the power negative 4 equal to 1 over 3. Last one, the seventh one, we have 1 over 3 raised to the power 2x, 1 over 3 raised to the power 2x equal to 27 raised to the power 4 minus 3x. So let's see how to solve them. 2 raised to the power x equals 64. The law is saying that a power n equal to a power n. So the base must be the same. So we can express this 64 as 2 power 6. To get here 2, here also 2. Hence, you cannot equate the powers. So hence, x is also equal to 6. So simple. I, 3 raised to the power 2x equal to 1 over 81. Now, if you want to apply that law, then we have to push 81 up. As usual, we push it up, it becomes 81 raised to the power negative 1, as you see here. 81 power negative 1 is the same as 1 over 81. So we are having here 3 here, but you can also get 3 here. So 81 is the same as 3 raised to the power 4. So 3 raised to the power 4 times minus 1 becomes 3 raised to the power negative 4. Therefore, we have 3 power 2x equal to 3 power negative 4. That's 1 over 81 here. So now the bases are the same. So you can just equate the powers. Hence, we have 2x equal to minus 4. By dividing here by 2, here by 2, we have x equal to negative 2. The third one, 2 power 3x minus 4 equal to 1 over 128. We have to push 128 up to become 128 power negative 1. So we have this. So by expressing 128 as 2 power something, we are not going to have 2 power 3x minus 4 equal to 2 power negative 7. 128 is 2 raised to the power 7. So multiply by power negative 1 will give us 2 power negative 7. So now the bases are the same. Hence, you can equate the exponents or the powers. To get 3x minus 4 equal to minus 7, hence x equal to negative 1. Now look at the fourth example. We have 4 power 3x equal to 4 power 2x minus 6. Luckily enough, the bases are the same. Hence, we can just equate the exponents. So we are now going to have 3x equal to 2x minus 6. Hence, x equal to negative 6. I hope you are all following. Now take the fifth example. 8 into bracket 2 power 4x plus 3 equal to 4 power neg x plus 6. So at this side, we can apply the multiplication law here by expressing 8 as 2 power 3, as you see here. So this is the 8. Hence, by just taking one of these, it becomes 2 power 3 plus 4x plus 4. And that's what will give us 2 power 4x plus 6. Now, this 4 here must also be expressed as 2 power negative 2. And when the powers multiply, that will also give us 2 power negative 2x plus 12. Now, the bases are the same. Hence, we can equate the powers. So by solving the powers, we have x equal to 3 over 2. So we can go through how to solve it. Now, if you look at what we have here, x cubed times x power negative 4 equal to 1 over 3. Now, the base here is x, base here is x. So you can apply the multiplication law of indices here by taking one of the x's and then add the powers. So that's what will give us x raised to the power 3 minus 4 equal to, now push the 3 up to become 3 raised to the power negative 1. Now, we go further, we are not going to have x power negative 1 equal to 3 power negative 1. Now, since the powers are equal, then the base must also be equal. Hence, x equal to 3. The next one, I've solved a lot of things with you, so you should be able to catch up. 1 over 3 raised to the power 2x. So we have to push 3 power 2x up to become 3 power negative 2x equals now 27 power 4 minus 3x. Let's express this one 27 as 3 power 3. So I get the same basis. So we can now multiply the powers here to get this one. Or this one should be powers. There's a problem here. Or no. If we create the powers, so minus 2x equal to 3 into bracket 4x minus 3x. 3 into bracket 4 minus 3x here. We create this one to this one because the bases are the same. That's what we get. So by expanding and then solving, we have x equal to 12 over 7. I hope it's clear here. Okay. So I've given you some to try on your own. Do your best to solve them, all of them. Try them. So we can end today's meeting here. I'm hoping to see you at our next meeting. Thank you very much. Goodbye.